Here we are given a function, f of x comma y is equal to y cubed plus 3x squared y minus 6x squared minus 6y squared plus 2. And what we want to do with this function, we want to classify any local max, min, and saddle points, and we want to find the relative extreme points. Okay, so this will be a little bit of a long problem, but let's go ahead and tackle this out. So for part A, what we want to do is we want to classify and find any local max, min, and saddle points. So the first thing that you want to do is take all of the derivatives. So let's first take the first derivative. So the first derivative of this is with respect to x. So I'm going to take the derivative with respect to x of every single term. So this one doesn't have an x, so it's just going to go to 0. Now this one, we can get rid of the 3 and the y. So let me pull out the 3 and the y and then take the derivative of this x squared. And the derivative of x squared is just going to be 2x. Okay. Then we're going to take the derivative of 6x squared. That's just going to give me minus 12x. This one doesn't have any x's, so this is just going to go away, and so is the 2. So my f sub x is going to be 6xy minus 12x. So this is going to be my first derivative with respect to x. Okay, so let me just box that. So now my first derivative with respect to y, now I'm going to take the derivative with y. So here is a y. I'm going to take the derivative of that. That's going to be 3y squared. Then I'm going to take the derivative of the second term. I can pull out that 3x squared and take the derivative of that single y. The single y is just going to be 1. Okay, this one is just going to go away since there's no y. This one's going to be a negative 12y. And then this is just going to go away. Okay, so my first derivative with respect to y is going to be 3y squared plus 3x squared minus 12y. So here is my first derivative with respect to y. Okay, now what I'm going to do, just to help me out, and this will help me on later, I'm going to take the second derivative. So I'm going to take the second derivative with respect to x. So the second derivative with respect to x, here I can just take out the 6x. I'm sorry, I can take out the 6y and then take the derivative of x, which is just going to be 1. So it's just going to be 6y. The derivative of negative 12x is just going to be negative 12. So here is my second derivative with respect to x. And then I'm going to take the second derivative with respect to y. So this one's just going to be 6y. This one's just going to go away. Minus 12y, the derivative of that is just minus 12. Okay, so here's my second derivative with respect to y. Now, I need to also find my mixed partial. So f sub x y. So I'm going to take the derivative of this one with respect to y now. So I'm going to take the derivative with respect to y. So it's just going to be 6x. The derivative of y is just 1. Then the derivative of this thing with respect to y, since this doesn't have any y, is just going to be 6x. Okay, and you'll see why I wanted to take all of the derivatives, because later on they will be helpful when I'm classifying. Okay, so now I need to figure out what my critical points are. So I need to use, I'm going to take the first derivative, set it equal to 0 with respect to x, and also take my other one with respect to y and set it equal to 0. So this one's just going to be what? It's going to be 6xy minus 12x is equal to 0. Then I'm going to have this one, which is going to be 3y squared plus 3x squared minus 12y also equal to 0. Okay, so now this one seems a little hard to solve, so I'm going to solve for this one first. And what I notice here is that I can take out a 6 and I can factor out an x. And then what am I going to be left over? I'm going to be left over with a y, and then I'm going to be left over with a 2. So y minus 2 equals 0. So I can break this up. So 6x equals 0, y minus 2 equals 0. So x equals 0 and y equals 2. Okay, so I have two solutions here. So either x can be 0 or either y can be 2. Okay, so now which one, what are its counterparts? So let's try to figure that out. So when x is equal to 0, let's go ahead and solve what my y value is. Okay, so when x is equal to 0, so I'm going to plug in 0 into this equation. So I'm going to have 3y squared plus 3 times 0 squared minus 12y equals 0. So this thing is just going to go away. I'm left with 3y squared minus 12y equals 0. Here I can factor out a 3, and I can factor out a y, and I'm left with y minus 4. Okay, is equal to 0. So what I'm left with is 3y equals 0 and y minus 4 equals 0. So y equals 0 and y equals 4. So right here I have 2 points. I have when x is equal to 0, I have y equal to 0, and also when x is equal to 0, y is equal to 4. So here are my first 2 points. Okay? All right, so now let's look at when y is equal to 2. Okay, so when y is equal to 2, what am I going to get? So when y is equal to 2, I'm going to go ahead and plug that back in there. So 3 times 2 squared plus 3x squared minus 12 times 2 is equal to 0. Okay, so what is this going to give me? This is going to give me 3 times 4 plus 3x squared minus 24 is equal to 0. This is going to give me 12 plus 3x squared minus 24 equal to 0. When I combine these two, I'm going to get 3x squared minus 12 is equal to 0. I can move the 12 over. So I'm going to get 3x squared is equal to 12. Divide the 3 over. X squared is equal to 4. And when I take the square root, I also have to add plus or minus. So x equals plus or minus 2. So this tells me I have 2 additional points. So these x's and this y, so I'm going to have 2 additional. It's going to be 2 comma 2. And then when x is negative 2, y is going to be 2. So here are my points. So let's write them down. It's going to be 0, 0. It's going to be 0, 4. 2 comma 2. And negative 2 comma 2. Okay, so these are going to be my 4 points. Now, these 4 points are either going to be local max, local min, or saddle. Okay, so how do I know that? So in order for me to do that, I need to figure out my d value using the d test. So d, if you remember, is equal to f sub xx times f sub yy minus f sub xy whole quantity squared. Okay? So if I look up f sub xx, well, I already figured that one out. If I go back up, f sub xx was this one. 6y minus 12. So that was 6y minus 12. So this thing is going to be 6y minus 12. Now f sub yy, so over here, another 6y minus 12. Okay, 6y minus 12. And then minus f sub xy squared. F sub xy was just this 6x. Okay, so this is going to be minus 6x whole quantity squared. Okay, so what you can do, you can go ahead and FOIL this out if you want to, or you can just leave it as is and then just plug in the point. So now what we got to do is the most tedious thing, is plug in every single point. Okay, so now let's first start off with 0, 0. So when you have 0, 0, what is going to be my d value? D is equal to, so I'm going to let me plug in 0, 6 times 0 minus 12 times 6 times 0, oops, minus 12 minus 6 times 0 squared. Okay, so here this is going to go away, so I'm going to have a negative 12 times another negative 12 minus a 0 squared. This is going to be 144. 144 is a positive number. Okay, so remember, when d is positive, we also have to check the second derivative, f sub xx. That also has to be, that can either be positive or it can either be negative. Okay, so let's see. F sub xx was 6y minus 12. Well, when I plug in the 0, I'm going to get negative 12, which is negative. Okay, so when this is negative, then what we're going to have a maximum. So remember, if D is positive and f sub double x is negative, then we're going to have a max. Okay, so in this case, D is positive and then the second derivative is negative. So 0, 0 is going to be a max, a local max. Okay, so that's my first one. Okay, now we got to do the next one. Okay, so 0, 4. So now let's look at 0, 4. So D is equal to 6y minus 12, 6y minus 12 minus 6x whole quantity squared. Okay, so let's plug in the 0, 4. So I'm going to have 6 times 4 minus 12, 6 times 4 minus 12 minus 6 times 0 squared. So this thing is going to go away. Here I'm going to have a 24 minus 12. Here I'm going to have another 24 minus 12. So I'm going to have another 12 times 12, which is equal to 144. So here I have another positive. Okay, now we got to check the second derivative since this is positive. So f sub xx, which is equal to 6y minus 12. Let's see what that is. So when we go ahead and plug in the y minus 12, I'm going to get 24 minus 12, which gives me 12. 12 in this case is positive. So when D is positive and the second derivative is also positive, what we have is a minimum. So this point is going to be a local min. Okay. All right. We're almost done. 2, 2. So 2, 2. Let's plug this into D. I'm going to have 6y minus 12, 6y minus 12 minus 6x whole quantity squared. So I'm going to have 6 times 2 minus 12, 6 times 2 minus 12, minus 6 times 2 whole quantity squared. So here I'm going to get 12 minus 12 times 12 minus 12 minus, this is going to give me 12 whole quantity squared. This thing is just going to be 0, and I'm going to get negative 144, which is negative. Now, whenever D is negative, we don't need to check the second derivative because that automatically tells me that it's a saddle point. When D is less than 0, we have a saddle point. So this thing is saddle. Okay. Now, my last one is going to be negative 2, 2. So negative 2, 2. So D is equal to 6 times 2 minus 12 times 6 times 2 minus 12 minus 6 times negative 2 whole quantity squared. So we already figured out what this was. This was just 0. This is going to give me a negative 12 squared. Well, this negative 12 squared is just going to be, the negative stays here, then I have 144. And this is just going to be negative 144, which is still less than 0. So this thing is going to be a saddle point. Okay. All right. So that was a long process, but we were able to classify all 4 points. Okay. So it's a long process that you have to kind of go through. But this is basically what you want to do. Find the first derivatives. Just figure out all of the derivatives so that you don't have to find them out later. Find our critical points by solving the systems of equations. Right. Once you have all your points, go ahead and use the d-test to try to classify each of the other ones. Okay, so in the next video, I will go ahead and do part B.